ladies and gentlemen. Today's video is the first video of our new unit. Our new unit is all about integers. You may remember from one of the first lessons of the school year that we learned what integers were very briefly. They were in that Venn diagram with the different kinds of numbers. An integer is any whole number, 0, 1, 2, 3, on and on and on, and all of those numbers opposites. So we have -1, -2, and -3. Integers are the whole numbers and their opposites. Our objective, what you should be able to do by the end of class today, is I can find the additive inverse of any given number, and I can use concepts of additive inverses to calculate addition and subtraction problems mentally. Before we can really jump into this, though, we have to get some definitions squared away. So go ahead and put a little line going across your notebook. Keep this on the same page and write definitions. Our first definition is going to be of additive inverse. And you guys know this concept. You just might not know the term, but the term is important for you to memorize. An additive inverse is what you add to a number to get 0. So let's say I have the number 6. The additive inverse is -6 because 6 and -6 cancel out to be 0. You can think of it as opposite because really that's what an additive inverse is. The additive inverse of 10 is -10. The additive inverse of -15 is +15. The second definition we need to know about is integer. And I kind of talked about it at the start of this video. Integers are the whole numbers and their opposites. Please stay away from saying that integers are negatives. That is not necessarily true. All negatives are integers, but you also have the 0 and all of your positive numbers. So when I ask you on a test or a quiz or in class, what is an integer, don't say negatives. Say the whole numbers and their opposites. Let's go ahead and do a couple practice things on finding the additive inverse. I don't think this is going to be too difficult for you. Draw another little line in your notebook on the same page. Write additive inverse practice. You don't have to write this section here. This is just giving you instructions right now. And write all of the different numbers that I have going down this side. I'm going to count down from 10. Make sure you get the video paused before I'm done. And while it's paused, I want you to try and find the additive inverses of each number shown. All right, here goes. 10, 9, 8, 7, 6. Hit pause. 5, 4, 3, 2, 1. Okay, I have put up the correct answers for the additive inverses. If you didn't get it right, please take a minute to figure. Sorry guys, I got pulled away in the middle of recording the video. I can't even remember where I stopped, but I'm just going to pick up from where seems right. So, moving right along, we talked about the additive inverses. Let's go ahead and talk about our next topic. On the next page of your notebook, go ahead and put the title, Using Additive Inverses for Addition of Integers. Integers, just to remind you, are the whole numbers and their opposites. Now, I want to take you back in time a little bit to when you were a little kid in elementary school and you were learning how to add numbers. Let's say, for example, you had 12 plus 8. Your teacher might have said to you, hey, guess what you can do? You can take that 12 and split it up into a 10 and a 2, and then you have this plus 8. And many of you knew your math facts well enough to say, oh, well, 2 and 8 is 10. I know that. So I can turn this into 10, and I have 10 plus 10 equals 20. That's called using compatible numbers. I'll go through another example in case that was too fast for you. Maybe you had, let's see, 16 plus 24. You could have taken 16 and split it up into 10 and 6, and taken 24 and split it up into 20 plus 4. Then, using what you know about your basic math facts, you could have said, oh, look, there's 6 and there's 4. That adds up to 10. And then I have this 20. And then I have this 10, and that's a really easy math problem to do. 10 plus 20 plus 10 is 40. If you never did that in elementary school, you might want to rewatch that part. It's all about splitting up numbers in a way to help you solve the problem. We can do that with integers also, guys, and it's really kind of cool, I think. Of course, I am also a math teacher, so I think anything having to do with math is awesome. But go ahead on like the second half of your page. Make sure you wrote those example problems on the top half. And now on the second half, write, but now, additive inverses. Let's say I have a number that has integers. And I have, for example, 6 plus negative 10. When we looked at compatible numbers as an elementary school kid, you split numbers up in a way that made sense. We can do that with the integer. Negative 10, this number right here, we can split that up into negative 6 and negative 4. When we do that, we can use what we know about additive inverses. Bring this 6 down here. This 6 and this negative 6 cancel each other out. They add up to equal 0, which leaves this problem easy. It leaves you with negative 4. We split up 10 into negative 6 and negative 4, and then we used our positive 6 and our negative 6, canceling, leaving us negative 4 left over. This is not a familiar concept to you guys. This might kind of make your brain go, what? And that's okay. Let's go through another example. Write these in your notebook, okay? Let's say I have 12 plus negative 8. I'm looking for a way to make additive inverses. I can take my 12, and I know that 12 is 4 plus 8. That's what I'm looking for, guys. I'm looking for the additive inverse of my negative 8, and I found it. So this 8 and this negative 8 will cancel each other out, and all I'm left with is this positive 4. Was the second time a little better? Hopefully. If not, rewatch it. Let's go through and actually work some practice problems, several practice problems. I'm going to go through them kind of quickly, a little faster than I did the last problem. Watch it through once. If you're lost, go back and watch it again. Pause throughout if you need to at my different steps so you can figure out how on earth to do this. Let's take a look at our first problem. Oh, I'm sorry, I forgot to mention, this can go on the next page of your notebook. Put example problems on the top of the page. So this first problem, we have 6 plus negative 15. I can take this negative 15 and split it up to negative 9 and negative 6. Those are the parts of negative 15. If I rewrite my expression, I'm going to have 6 plus negative 9 plus negative 6. And I have two numbers that are additive inverses that will cancel each other out, leaving me with my answer of negative 9. Let's go through the next one. Number 2. I have 3 plus negative 10. I covered it up, sorry. I'm looking for the additive inverse of 3 to try and cancel it out. So I'm going to take my negative 10, split it up into negative 3 and negative 7. If I then rewrite my expression, 3 plus negative 3 plus negative 7, once again, I'm going to look for my additive inverses. We know that additive inverses cancel each other out to equal 0. So I am left with this negative 7 right here. Next one. If you need to stop and go back, please do, guys. Rewatch what we did on this previous page, if that's going to be helpful to you. So now I have negative 10 and 4. I'll take my negative 10, turn it into negative 6, negative 4. Rewrite my expression. I have negative 6 plus negative 4 plus 4. There is my additive inverse pair right there. They cancel to equal 0, and I am left with negative 6. Down here, I have negative 5 plus 1. I'm trying to find the additive inverse of this 1 right here. So I'm going to split negative 5 up in a way that's going to give me a 1. So negative 1, and then what's left over from negative 5? Negative 4. Rewrite my expression, negative 1 plus negative 4 plus 1. Find my pair of additive inverses right here. They cancel each other out, and I'm left with the answer of negative 4. And one more for you. I threw this one in because I thought it was kind of cool. Instead of making extra work for yourself and splitting up numbers and trying to find additive inverses, I hope that you would recognize from the very beginning that negative 8 and positive 8 are additive inverses, so together they equal 0. What I'm going to do now is I'm going to give you some extra ones to do on your own. I want you to try and figure out how to do these. I gave you some bigger numbers, but you go through the process exactly the same way. You need to split negative 40, for example, up into two numbers, one of which is the additive inverse of positive 26. So take a minute. I'm going to count down from 10, and then the answers are going to pop up on the screen. So please make sure that you have completed your work by then, that you have paused the video before I do that. So here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Pause. All right, guys, here are my final answers for this problem. You can see how I broke each problem up. I took my number and I split it up into two parts. And then I used my canceling of my additive inverses, and what was left over became my answer. If you missed any of these, go back. You might have just made a little silly mistake. Look at the work I did, look at the work you did, kind of compare them and see where the mistakes are. Now, what I'd like you to do at this point in time is on Edmodo, I want you to put a response when you turn in this assignment, okay? And if you don't have the response there, I'm not going to give you credit for the assignment. So the question that I'm going to ask you is, are you ready? Okay, ladies and gentlemen, this is your prompt for your reflection. Please write a couple sentences, type it into Edmodo, and tell me how you could explain in words, not using math symbols, how you would solve the following problem using the ideas of additive inverses that you learned today. And the problem is 6 plus negative 10. If you are doing this homework assignment on a mobile device of some sort and typing is quite difficult on that mobile device, please write it on a separate piece of paper that you can then bring in and give to me, although I far prefer it on Edmodo, so I can give you feedback tonight while I'm at home. Thank you, guys. I hope you enjoy your slightly shorter video today, only 13 minutes. Go, Mrs. Ott. And I will see you in class tomorrow. Thanks. Bye-bye.